Observability and SRE Part 6. This episode has 13 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. GCP networking. How would you design GCP shared VPC, service projects, firewall rules, private service access, DNS, and service networking for a multi-team platform? Here's a strong way to approach it. Use a host project owning the shared VPC with subnets per environment or region, and attach service projects per team so each team deploys resources into the shared network without owning networking config themselves. Centralize firewall rule management in the host project with tag-based rules rather than IP-based. Set up private service access for managed services, Cloud SQL, etc. And use Cloud DNS private zones for consistent internal service discovery across all service projects. Nice. Let's continue. Question 2. GKE upgrades. A GKE cluster upgrade caused service disruption. How would you design a safer upgrade strategy for control plane, node pools, PDBs, and workloads? Here's a strong way to approach it. Upgrade the control plane first. GKE manages this with minimal disruption for regional clusters. Then roll node pools using surge upgrades. Create new nodes before draining old ones, rather than in-place upgrades. Ensure every workload has a pod disruption budget so the upgrade respects minimum availability during node drains. Test the upgrade path in a staging cluster first, and schedule production upgrades during low traffic windows with monitoring dashboards open to catch regressions early. Great. Moving on. Question 3. Helm. How would you structure Helm charts and values for repeatable deployments across environments without creating configuration drift? Here's a strong way to approach it. Use one chart per application with a base values YAML holding sane defaults, and environment-specific values files, values dev YAML, values prod YAML, that only override what genuinely differs, rather than duplicating the entire values file per environment. Store values files in version control alongside the chart. Template only what needs to vary, and use a GitOps tool, Argo CD, to reconcile the deployed state against the values file so manual Helm upgrade runs can't silently drift from what's committed. Alright, next question. Question 4. Network policies. A service should only receive traffic from one namespace and one ingress gateway. How would you implement and validate Kubernetes network policies? Here's a strong way to approach it. Start with a default deny network policy in the target namespace, then add an explicit allow policy with pod selector or namespace selector matching only the permitted source namespace and the ingress gateway's pod labels. Validate by attempting a connection from an unauthorized pod or namespace, should fail, and from the two permitted sources, should succeed, and confirm the CNI plugin and use actually enforces network policies, since some default CNIs don't without additional configuration. Let's keep going. Question 5. Service mesh. When would you introduce Istio or Anthos service mesh, and what are the operational risks around MTLS, traffic splitting, retries, and observability? Here's a strong way to approach it. Introduce a service mesh once you need consistent MTLS across many services, fine-grained traffic splitting for canary or A/B testing, or unified observability without instrumenting every service individually, not as a default for every cluster, since it adds real operational complexity. Risks include sidecar resource overhead, debugging difficulty when mesh-level retries mask real failures or double up with application-level retries, and MTLS misconfiguration silently breaking traffic if strict mode is enabled before every service is enrolled. On to the next one. Question 6. Progressive delivery. How would you implement canary or blue-green releases using cloud deploy, Argo rollouts, metrics, and automatic rollback? Here's a strong way to approach it. Use cloud deploy or Argo rollouts to shift a small percentage of traffic, e.g. 5 to 10%, to the new version. Define success metrics, error rate, latency, business KPIs, that are automatically evaluated during the canary window via cloud monitoring or Prometheus, and configure automatic rollback if metrics breach thresholds rather than requiring a human to notice and act. Gradually increase traffic percentage on success, and keep the rollback path as fast as the promotion path so a bad release is reverted in minutes, not hours. Good. Here's another one. Question 7. Release readiness. A production release passed CI but caused customer impact. How would you design production readiness checks and release gates to prevent this? Here's a strong way to approach it. Add release gates beyond CI, a canary stage with automated metric validation, a load or smoke test against a staging environment that mirrors production traffic patterns, and a readiness checklist. Rollback plan documented. On-call aware. Feature flagged if risky before full rollout. Treat CI passing as necessary but not sufficient. The real signal that a release is safe comes from observing real or synthetic traffic against it before it reaches 100% of users. Nice. Let's continue. Question 8. Incident leadership. You are the incident commander for a GKE outage. How would you manage technical debugging, stakeholder communication, timeline, mitigation, and postmortem? Here's a strong way to approach it. As incident commander, focus on coordination rather than personally debugging. Assign a technical lead to drive investigation. Designate a scribe to keep a timeline. And own regular stakeholder updates on a fixed cadence even when there's no new information. Since silence erodes trust during an incident, prioritize mitigation, rollback, scale, traffic shift, overroute causing while impact continues, and once resolved, drive a blameless postmortem with concrete action items and owners, not just a narrative. Great. Moving on. Question 9. RCA. Walk me through how you would write a strong RCA for a repeated Kubernetes outage and turn it into preventive engineering work. Here's a strong way to approach it. A strong RCA documents the timeline, customer impact, the technical root cause, not just the trigger. Dig into why the system allowed that trigger to cause an outage, and explicitly separates the immediate fix from the systemic prevention work. Since this is a repeated outage, the RCA should call out why the previous fix didn't prevent recurrence, and action items should be specific, owned, and dated, converting the recurring pattern into a permanent guardrail, test, alert, or architectural change, rather than another one-off patch. Alright, next question. Question 10. Error budgets. How would you explain error budgets to product managers and use them to make release decisions? Here's a strong way to approach it. Explain it as a shared budget for imperfection. If the slow allows 99.9% availability, that 0.1% is a budget the team can spend on releases, experiments, and acceptable risk. Once it's exhausted, the team should slow down and focus on reliability rather than shipping new features. Use it in release decisions concretely. If the error budget is healthy, ship faster and take more risk. If it's nearly exhausted, require extra review or freeze non-critical releases until reliability recovers, making the trade-off data-driven instead of political. Let's keep going. Question 11. ELK or OpenSearch. When would you use ELK or OpenSearch in addition to cloud logging, and how would you manage index cost and retention? Here's a strong way to approach it. Use ELK or OpenSearch when you need advanced full-text search, custom dashboards, or cross-cutting analysis that cloud logging's query language doesn't support well, or when logs need to live outside GCP for multi-cloud or compliance reasons. Manage cost with index lifecycle management, hot indices for recent, frequently queried data on fast storage, warm or cold tiers for older data, and automated deletion or archival to cold storage past a retention window, plus filtering out low-value log volume before ingestion rather than indexing everything. On to the next one. Question 12. Admission controls. How would you enforce Kubernetes security standards using Gatekeeper, Kyverno, or admission controls without blocking developer velocity? Here's a strong way to approach it. Start policies in audit or dry run mode so violations are visible without blocking deployments. Give teams a grace period and clear error messages pointing to exactly what needs to change. And only move a policy to enforcing once most workloads already pass it. Keep the policy set focused on genuinely high-risk violations, privileged containers, missing resource limits, public load balancer without review, rather than blocking on stylistic preferences, which is what erodes developer trust in the guardrails. Good. Here's another one. Question 13. Security Command Center. How would you operationalize Security Command Center findings into triage, ownership, SLAs, and remediation workflows? Here's a strong way to approach it. Route SCC findings automatically into a ticketing system tagged with the owning team, derived from resource labels. Assign SLAs by severity, critical findings remediated in days, low severity in weeks, and track aging findings in a dashboard. Leadership reviews regularly. Suppress known false positives explicitly, with a documented reason and expiry rather than letting teams ignore the noise, and periodically audit whether closed findings were actually fixed, not just marked resolved. Nice. Let's continue. That wraps up this episode. Nice work practicing, and see you in the next one.